Hi all, in this class we are going to actually learn about a little bit of supervised learning algorithms. We have already covered a lot about the supervised learning algorithms in the previous classes, right? But just to recap on what we have actually learned about the supervised learning algorithms, just wanted to give you a glance about what all we have learned before. As you already know, supervised learning algorithm actually uses labeled data, right? So it uses labeled data. Why? It uses those data to train the models, and we also need to find out that the data point has an input output pair. Why? Because for the training we are providing both the inputs and the outputs to the machine or to the algorithm that we are going to train, right? And when we move over to the testing phase, we basically gives only the input and makes the machine predict the output, right? And we compares the test output and the predicted output, right? So this is what we basically does. So basically if you look at the supervised learning algorithms, we do have two different types. One is classification and one is regression. And if you have a discrete data as the outcome, we basically go for classification, right? And if we have continuous data, which is the outcome, and we will go for regression. And every process would be considered as an IPO. So you have some data and you need to model, you need to come up with your own model, and you need to predict the outcomes, right? And moving over to certain examples, so there are various algorithms. There are a lot of algorithms which are available for supervised learning models. But however, let's take this example. Like, so whenever you get a problem, the first thing which you have to keep in mind is that, say, consider for example email filtering, right? So if email filtering, and email filtering simply means that if a mail is fishy, then it has to go to the spam folder, otherwise it should go to the inbox folder, right? That's all. So our aim is nothing but to classify the emails as the spam and the not spam, right? Or spam, or it should go to inbox, right? So what all could be an input, right? So the input is nothing but the various kind of columns which are there in your data set, right? So what could be the features that we need to consider in order to make sure that a particular email content is actually spam or not, right? So the first one itself is the email content, right? We should have the text of the email, then we should have the sender address and the subject line. And output is nothing but, we have to classify it. So it's a binary classification. Why it is a binary classification? Because either we are putting the email content onto the spam or to the not spam, right? So when we are actually classifying the emails, so these are all the various features which we have, which is email content and the sender address, subject line. Maybe you can include the number of the links and the number of the emojis. All this information can be added as the features here. And say for example here we are selecting naive-Bayes algorithm as the model. So once we provide this, we get the trained model, and the model will in fact predict whether a particular email is spam or not, right? So is it only naive-Bayes? No, we do have lot of algorithms which are available. So one of the other algorithm is basically the logistic regression, right? So these are all algorithms which can actually work for the categorical data like spam, not spam, yes or no, or true or false kind of, discrete values. Now coming back to the next example, which is actually this fraud detection. So we have to identify the potentially fraudulent transactions, right? So what all could be the inputs, like the amount itself, the location, the frequency, right? And so with all those information, the date and the time and all those informations definitely, and we will predict whether a particular transaction is fraudulent or legitimate. So we do have other set of algorithms which are called as the decision trees and the random forest. Random forest is actually one of the most commonly used algorithms, which actually works well and gives a lot of accurate results for many data sets. Now another example is medical diagnosis itself. So predict the presence of a disease, right? So whether the disease is there or not. So patient data like the age, symptoms, lab results, etc., which is there, and you have to diagnose whether a particular disease is present or not. So Normally when we do a particular, say when we used to do the corona test or the COVID test, we used to say whether it is positive or negative, right? So as simple as that, in the same way. And we do have the very important algorithms like support vector machines, which is called as SVM, and they are very powerful algorithms, classification algorithms or supervised learning algorithms which are available. And there are neural network algorithms or deep learning based algorithms which actually can give you enter into a lot of in-depth details and give you the right output, whether a particular disease, because all these are very critical data where you cannot make a mistake. So there is, yeah, your algorithm can make a mistake, but you should make sure that the algorithm should not make a mistake, right? So these are all very sensitive applications that you need to be really careful about. Now coming back here, so yes, so as anything and everything is concerned here, also we do have challenges. So the first challenge which we will face is basically the data quality itself, right? So if the data has a lot of sparse data in the sense like a lot of missing values, a lot of inconsistencies, inaccuracies, and etc., then definitely when we are feeding the model with such kind of a data, we are going to end up with a lot of inaccurate results as well, results and insights as well. And the next one is actually overfitting. So overfitting is nothing but, say if your model is seeing a lot of data, say you have the training data, and say you have, just imagine you have a data set with 100 instances in the sense the rows or records. Okay, so the rows in a particular data set, I will call them as instances or observations or records, any of these terms will do. And the columns, I would call them as attributes or features, right? So if you are, say you have 100 observations and you are splitting your data as 80-20, it's a pretty good split. But just imagine I'm just giving all the data onto the model, and if the model knows about everything, then it tries to overfit, right? And underfit is nothing but a case where you are not providing enough samples, right, for the model to train. So that is actually underfitting, so it can cause a lot of inaccurate results and insights. And then comes the data dependency itself. So if you have require large volumes of label data, that is required to provide you accurate results. Otherwise, there is a higher chance that you would get inaccurate results. And the bias and the fairness, say if you have a data set with lot of homogeneous data, and in your test set you have a lot of heterogeneous data which is different from the data which is actually the model has been trained with, then there is a lot of bias and fairness which can help, right? So you need to actually form a trade-off, a balance between the data which is inside that you are actually feeding to the model itself. So it should have both the variance and also the bias so that the model can train in both ways. So there should be some balance to be kept so that you get the most accurate results. And finally, but not the very important point is that the computational cost itself. So if you want to use very complex models, definitely the computational cost is going to be on a higher side, right? So these are all the various challenges that you might face in a supervised learning, because you do have a training phase, and then you get your trained model, and with your trained model, when the trained model is actually fed with the test data, you are going to get your results, right? So this is definitely going to be having a lot of challenges. Now coming back here, so this is again which we have already told. So the classification algorithms actually are used when we are going to predict the discrete categorical values, and for the regression, and we are going to use the continuous numerical values. And how can we select the right algorithm? Actually it depends upon the data itself and the model interpretability and complexity. So this is a very important term, model interpretability. So based on the data, so there is no existence for any model like kind of an isolated existence. Always a particular model. You can never say that a particular model is works well for many kind of data. No, it will never work that way. You can only say that a particular model will work for a particular set of data with this parameter settings. right? Only that much you could say. You can never say that a model will work well for any data. No, a model will work for a particular data with the particular parameter settings, and it will give you certain results. So the nature of the data, you should have a clear understanding about your data, and you should select the model based on the data and the target which we are gonna work with, and you should decide the complexity of your model based on the data, right? So your model should be able to analyze and understand what is in the data in a better way. So you should select the models in such a way that is suitable for the data, right? And now the last one is nothing but based on the models you select, your accuracy and the computational efficiency basically differs. So you will select the metrics, evaluation metrics based on the model that you have selected, and with the help of the computational efficiency, you will be able to understand whether that particular algorithm or model works well for this particular data, right? So this is very, very important. Now coming back to the selection of the algorithm itself, so definitely you have this nature of the data and the problem type itself, whether it is regression or classification. Based on that you can select the algorithms and the desired output, whether do you want a discrete output or a continuous output. So is it just a prediction, or is it just a fast computation, or what are you going to do with the data itself, and the performance and the complexity, right? So do you want some deep learning models to do something in depth, or you just want some linear computational models which is just used for efficient computational purposes. So now these are some examples. So we do have a lot of supervised learning algorithms available. So we have decision tree, we have linear regression, logistic regression, support vector machines, etc. So these are all few of the supervised learning algorithms which are available. So now let's get into the first supervised learning algorithm, or the first algorithm that you are going to learn in this course, artificial intelligence. Okay, so the first algorithm is basically called as KNN. Okay, so the KNN, by the name KNN, it is very clear that it is K nearest neighbors. Okay, so it is nothing but K nearest neighbor. So that's the meaning of that particular what do you mean to say, that's the meaning of this, so that is the meaning of this, KNN, right? So this is the meaning of K nearest neighbors. Now the next thing which I want you to first of all understand is that, say, there are many algorithms like naive-Bayes algorithm, logistic regression, which all actually hovers around a mathematical formula. Okay, but for the case of K nearest neighbor, we don't have a fixed equation, right? So that's why they are called as non-parametric. So this could be one of your quiz question as well. So a non-parametric, so the KNN algorithm is basically non-parametric. So does that mean that there are no parameters at all, ma'am? It doesn't mean like that. It is actually function with parameters, but there is no fixed equation. You can actually provide the parameters based on the application that you work with. Now another point which you have to understand here is that it is actually instance based, right? So I already told you, like, say if you have a data set, just imagine like you have a data set, right? In this data set I will call each of these rows as the instances. So each one of these rows are basically instances for me. So each of these are basically instances for me, and if I have columns I will call them as, these are nothing but the features, right? So this actually provides me as the features, right? These are the features. So now what do you call this KNN as instance based? Okay, so say if you are actually giving 80% of the training samples, it remembers all of those 80% of the training samples. Or you could otherwise say that, this is that naughty algorithm which actually takes all the data as this training sample. Or what you could say is that it remembers all of the data for its classification and regression tasks. Okay, so understand, KNN is nothing but a non-parametric because it doesn't have any fixed equation, and also you have to understand that it is instance based, because if you are actually providing some instances or records to the algorithm, it actually remembers about it, okay, and it works based on that. Now what does it does? What it does is nothing but it makes prediction, and it makes prediction based on what is very, very important. It makes based on k. Okay, so what is this k? K is nothing but the nearest neighbors, the number of the nearest neighbors. Okay, so k is nothing but the number of the nearest neighbors. Okay, so has no training phase. So this is one particular supervised learning algorithm which does not have a specific training phase, and what it does is that the entire data will be taken as the training itself. Okay, so it will read the entire data and it remembers about the entire data and keep it over there and makes the decisions whenever needed. It just goes around and see what the data is and it just makes the decision. So it simply stores the data and makes decisions when needed. So that is what it actually again goes back here. So instance based means, you know, you have your data, and whole of this data is basically taken like a training data. That means that I know the complete details about the data, and with that information I will predict, right? So that is something which you have to keep in mind. So this itself is your training, you know, samples, right? Now this is one simple example which you could see. Say you have lot of, you know, data points here. So I will say that, you know, each one of them is a data point, right? And now you need to actually figure out whether this particular data point will fall into this cluster, or, you know, sorry, I could say that, you know, this category or this class or this blue class or the red class, right? I want to categorize it, right? So this is what my task is about. Say if I have data points, all the data points I will put it in the x and the y axis, right? So x and y axis, and I want to make sure that whether this point will fall into either the blue class or into the red class, right? And now overall I can actually use this KNN. The KNN I can use it for image recognition or recommender systems, right? And the medical diagnosis. So you would have already seen, like, you know, the handwritten classification, handwriting classifications, and, you know, similar people liked, you know, this you would have, you know, like in Temu, Amazon and all, you would have already seen all this in a multiple times, right? And the image, the medical diagnosis. So KNN works well when the data is not too large, because, you know, KNN is low dimensional. So understand, this is a very important point. KNN works well only if your data is not very large. Now coming back here to the KNN, so what is the algorithm? So this is the algorithm for KNN, and I think, you know, this is the smallest algorithm ever you can see ever in a machine learning scenario. Okay, so basically what happens is that it stores all the data. So this is all your data is your training samples. Okay, so there is nothing like, you know, you cannot save anything. So this is your whole data will be considered as your training examples. And now when a new input comes, what it does, it will take the distance of the new input with all other data points, all known data points, right? So how can I do that measure distance? I can measure the distance by various distance measures which are already available. And what will I do? Then comes the k into the picture. So we have already set a k. So I will pick the k nearest neighbors to identify whether this particular new point is into new point is actually in the in which of the categories, right? Say if I have this particular new point, what I will do is that I will find out the distance between this point and this point, this point and this point, this point and this point, and in the same way I will find out the distance of this point to all other points in the space, right? Then what will I do? Then I will say if my k is equal to 3, if my k is equal to 3, okay, just imagine my k is equal to 3, then what I will do is that I will fix this. Okay, I will fix this k and see that, okay, two different points are basically red, so probably this one will fall into this category, right? So this is how I will do. So when you look at it, you have a data collection and you have the feature selection which is happening as always for any of the algorithms, and then you will measure the distance, right? And you will identify the nearest neighbors, and based on that you will rank and find out what your prediction is ultimately. So for classification, we will vote on the most common label, okay? And for regression, we will simply calculate the average values of the k neighbors. So this is what we do for classification and the regression. Now, how do we choose k? Right, so this is another main question that you will all have it in your mind. So, okay, ma'am, you're talking about this k, and you're talking about this k as the nearest neighbors, right? But how do we select the k? So, k is basically a hyperparameter. Okay, so what do you mean by a hyperparameter? It's just a value which you choose before running the algorithm, so that it controls the neighbors that are used, right? So, based on this k values only, our final, the test point will be fallen into this class A or class B, right? So what happens when your k is small? Okay, when your k is small, what happens? There is a higher chance for overfitting, and when your k is actually very large, there is a higher chance for underfitting, right? It will cause underfitting because the classes are not well separated, right? So this is two issues. Okay, now we can also select k values as the odd values. Why not? What is the problem with the even values? Why not we cannot select even values? So just imagine, like, you have a bunch of data. Okay, so you have lot of data points, right? These are all your data points, and just imagine this is in class B. Okay, and this is the data point which you have to actually identify, right? And just imagine, like, this is in class A, and you have another data point here which is actually in class A. Okay, class A, right? And here there is another data point which is in class B. Okay, so now normally what you does is that, this is the data point which you have to actually find out the which class it will fall into. So you will find out the distance between this and this point, and this B point, and this and this point. Like, you will find out the distance of this particular point to all other data points. And now if your k is equal to 3, then just imagine, like, if these three are the smallest distance, right? So these three are the smallest distance. You will actually, if k is equal to 3, you will actually make sure that, you will make like this. You will, you will select A and B. So you will get 3 data points which actually into A and B. So it is very easy for you to actually identify that. You will take a majority. So this is more closer to 2 different points which are in the A. So I will say that, my new data test point actually belongs to A. Now just imagine you have a data set, right? Again, you have this particular point which you have to actually find out. But just imagine you have all, lot of data points here and there. But if you are taking the k as 2, what happens? Just imagine you are taking the k as 2. So what happens? Just imagine these two are the points which are actually closer. So you will get one point in A and another point in B, right? So again, it's a tie. So there is no tie breaker if you are actually taking your k as even. So that's why we always go for the k as odd values, because normally we get a tiebreaker, so that we can decide about which class this particular data has to fall into in an easier manner, right? So that's why we go for the odd values and not even values. Now another one which you have to keep in mind is that normally in many cases, normally we will go for trial and error method, and or we will also learn about something called as cross validation, which will actually help you to identify the k. So these are all the various methods for identifying the k values. Okay, so now coming back to what all are the distance measures. So we were actually talking about our algorithm, right? In this algorithm, if you see, you are actually considering all the training data, and when a new input comes, you have to measure the distance. And here they are actually saying, like, say example, Euclidean distance. So what are the distance measures? So how can you actually find out the distance between two data points? That is what you are going to say. Say if you have one data point here and another data point here, how will you find out the distance between them, right? So point A and point B is there. Say what would be the distance between these 2 points? So there are different ways for you to find out the distance between data points. So most commonly used one is basically the Euclidean distance. It's a straight line distance. So say you have the point 1, 2 and 3, 4 here. Then what you will do is that root of x1 minus x2 the whole square plus y1 minus y2 the whole square. This is the formula that we will use. So just imagine you have 1, 2 here and 3, 4 here. So 1 minus 3 the whole square plus 2 minus 4 the whole square, and you will find out the root of it, right? So that value will give you the Euclidean distance. So Euclidean distance is all, you can also have a squared distance for the Euclidean. So that is also basically possible, right? that is also possible, right? For the Euclidean distances, that is also possible. So if you put a square over here, you will get a squared distance. Okay, you will get a square distance. Say, just imagine like you have root of say if it is root of 25, right? Just imagine like root of 25, and you have something like a whole square, right? So what you will get? You will get the value as 25, right? You will get the value as 25, right? So in the same way, if you are actually doing a square distance, then your answer will be x minus x1 the whole square plus y minus y1 the whole square. That's all. So that such kind of distance is basically called as a squared distance. And then you have Manhattan distance. Manhattan distance is actually the absolute distances. So x1 minus x2 plus y1 minus y2, and this is mainly for the textual data, and this is like your vector, right? So you have direction and magnitude, right? This is the formula for it, right? So you will find out the magnitude, the cosine or the cos theta. So this is nothing but the cos theta you will find out, right? So this is exactly what you will do. So these are all the various distance measures which is available. And how will you choose the right distance measures? Definitely based on the data type and the problems to solve. So if it is numerical features and the distances are very meaningful, the height versus weight, such kind of things, you can go for the Euclidean distance by closing your eyes. And then Manhattan distance again, if you are having some ordinal values, right, then you can actually go for that. And cosine similarity works especially with the textual data or the high dimensional sparse data. You can document similarity, user preferences, and all those such case of things. You can see that you will use the cosine similarity. Now coming back here, we will see one example of the k nearest neighbor. So what you so this is actually the data set which is actually given to you. This is your data set. Okay, so in this data set, if you see how many features are there, there are two different features. So these are our features, right? So each of these columns, if you see, these are all the instances. These are all the instances, right? These are all the instances, and these are all your features, and this is actually the target label, right? Target or the output label. So this is nothing but the label. Why it is a label? Because you are mentioning about two different classes. What are the two different classes? One is actually the apple class, and the other one is actually nothing but the orange, right? These are the labels which you have. Now what is your task? So this data is actually given to you. So if the weight of a fruit is 150 and the color score is actually 7, there is a higher chance that it will fall into the apple class. And if the weight of the fruit is 130 and if the color score is actually 5, there is a higher chance that it will fall into orange, right? So this is how your data set looks like. Now your task is that if your weight, so this is your test data, right? So this is your test data. For this particular data, you need to predict whether this will fall into which fruit class, whether this will fall into the orange fruit class or whether this data will fall into the apple fruit class. This is your task. Okay, so you are given with a weight of 145 and you are given with a color score of 6.2. So you need to check whether, so you have 145, okay, right? You have 145, and here you have 6.2, right? You have 6.2. Now you need to decide whether it will fall into apple or orange, right? So this is what you have to actually identify. Now for that, what you will do, your algorithm is as simple as this, right? So when a new point comes, you measure the distance, right? So what you need to do, you need to find out the distance. So how will you find out all these distances? What you will do is that you will find out the distance between the points. So one of our main test points is actually 145, 6.2, right? So the distance between this particular point and the first point, distance between this particular point and the second point, distance between this point and third point, fourth point, like that we will find out the distance between all the points, right? So once you find out the distance between all the points, okay, now you will get all the distance measures here, right? Say, just imagine like, you will get the distance between, your 140, this as, say 5, right? You are getting the distance as 5, right? Maybe you are getting the distance of this one as say 3, okay, and say here you are getting the distance as 8, okay, 9, okay, and 10, okay, and here you are getting the distance as say something around say 9, okay, just imagine. So these are all the values. Now what will you do? So these are all the distance, so all these distance measures you will get, right, distances you get. Now you need to, what you need to do, you need to now the k will come in the picture. So what is our k? Our k has to be taken as 3, right? So now the k will come in the picture. So when the k come in the picture, what you need to first do is that you need to identify the first 3 lowest distances. So this is the lowest distance 1, then the second lowest distance is this, and the third lowest distance is this one, right? So we will take all the 3 lowest distances, right? We will take all the 3 lowest distances and we will check. Okay, what is the next step? Next step is nothing but we need to do a majority voting. Okay, so just imagine you got, say this as the first lowest distance and this as the second lowest distance and this as the third lowest distance. Just imagine, right? These are the ones. So what will you have? You will understand that there will be 2 apple classes and 1 orange class. Now how do we decide that how this particular point will fall into which of the class? We will do a majority voting. So what is a majority here? Majority voting is in apple. So we will decide that this when k is equal to 3, okay, for this particular data, this will fall into apple class, right? So this is how we will actually make sure that how the data point is actually falling into which class, right? So this is our KNN algorithm. So in KNN algorithm is very simple. You have your data, whole of your data will be stored and will be taken as the training examples, right? Now if a new data comes, you will find out the distance between this new data to all other data which is already there. So you can use any of the distance measures like Euclidean distance or Manhattan distance, or if it is textual data you will go for Jaccard similarity or cosine similarity, right? So now all our data are numerical, so we will go for Euclidean distance and we got all the distance between the data points. Then we will sort them. So then actually comes what comes in the picture, the number of the nearest neighbors comes in the picture. So based on trial and error method or taking an odd value or by some experimental basis, we will decide the k. Sometimes the k will be given in your question itself. So if considering k as 3 as given in the question, so what we will do now, we will find out the shortest 3 different distances, right? We will find out all the 3 different shortest distances, right? Distances. Then what we need to do is that we need to check whether all these 3 distances fall into which all classes, right? Say for example, or assuming that if 2 of the distances fall into 2 apple classes and 1 orange class, we will decide based on the majority voting, we will decide that our data point will fall into apple class. Say for example, we had 2 orange classes and 1 apple class, we would have decided that this data point would fall into the orange class. That's all. So that is why we take the k as an odd value. Why? Because if it is an odd value, there is a tiebreaker automatically associated with it. But if there is no k value, if the k value is even, then we will form there is a higher chance that we will end up in a tie. Okay, so this is nothing but your k nearest neighbor algorithm, or it is also called as KNN. So KNN can be used for both classification and regression. Okay, and now KNN works well for the low dimensional data where the similarity matters. Okay, so now one issue of your KNN is that there is a higher chance that overfitting can happen. Why? Because all the data points are actually taken as the training sample, so there is a higher chance for overfitting. So if your data set is small and if you have proper labels associated with it and you have only a very simple classification to be done, then go for the KNN algorithm. Okay, so now despite its simplicity, KNN accuracy of classification accuracy of KNN is strong, and in many cases as accurate as many other complex algorithms as well, right? And new training samples are added, one main drawback of your KNN is that the algorithm adjusts to count for new data since it is stored in the memory. So it is also called as a lazy learner. Why lazy learner? Because I already know all your data and it is in my memory. If you want to use it, you just use it. That's also, I'm a lazy learner, right? So that's nothing but KNN, right? Okay, so this is important. Now, so we have seen one algorithm which is nothing but KNN algorithm. So in KNN algorithm, it is a simple algorithm with just 3 steps. We will store all the data, and if a new data comes, we will measure the distance by using any of the distance measures. Then we will do a majority voting based on the k value, right? On the k value, and based on the classes which we got based on the k value, we will do a voting so that we get the right categorization for the test data, right? So this is nothing but a simple KNN algorithm. Now comes another algorithm. What is that? The another algorithm that we are going to see is logistic regression. But before moving over to it, let me just take you through the lab of this KNN. So I will take you through the lab for the KNN. So this is the lab which is there for the KNN. So as you all know that, you already understand that what happens here. What are we actually doing? We are actually loading the iris data. So we are going to work with the iris data set, right? So everybody knows that what is an iris data set by now. Iris is not an eyeball data set, it's a flower data set. Okay, how many classes, how many different types of flowers are there, right, in the iris data set? So if you see iris, right, iris Wikipedia, right, Wikipedia, you could see that iris is a simple and beautiful flower data set, right? Iris is a, one second, iris data set wiki. Okay, if you type like that, you will be able to see this iris flower data set. If you see, it is a flower which has got 3 different flower types. One is a setosa, one is versicolor, and the other one is virginica, right? So this is a data set with 3 different classes. Okay, so that is what we are actually talking about, and we are loading. And where can we find this? We can find this in the sklearn.datasets, right? So that is what we are getting, and we are loading the iris into, and we are giving the name by ourselves as iris dataset, right? So this is what it is. Don't worry about this bunch, you can just ignore that. And then coming over to here, what are we doing? We are simply printing all the features. Okay, so that is what we are basically doing here. We are simply printing and displaying the features and the target. So we are actually printing the feature name. So what are the feature names? Feature names are nothing but the column names or the attribute names, right? So you are actually going to work with the sepal length, sepal width, petal length, petal width, right? And all of them are in centimeters. And then the target names is nothing but the classes. You have 3 different classes, so setosa, versicolor, and virginica. And this is your target. So your target, you are actually having like 0, 1, and 2. That means that you have 3 different classes, which is setosa, versicolor, virginica, which is actually whose the labels are nothing but 0, 1, and 2. And if you see, there will be 150 observations for this, and these are all the original values of all the parameters, like so say if you see, if I take this first one, this 5.1 is nothing but the sepal length of the first data, and 3.5 is nothing but the value of the sepal width, 1.5 is the value of the petal width, and 0.2 is the value of the petal width, right? So based on this, you need to categorize whether this particular flower with this particular features will fall into setosa, versicolor, or virginica. So it is actually falling into setosa, right? So this is how the data looks like, right? Now coming back to what is the target data. So the type of the target data is actually a NumPy ND array, the n-dimensional array, and here also it is an n-dimensional array. Now you are going to store your data in the target variable. So your data means your main inputs or the features, you are actually storing it in X, and your target or the label column or the output column is actually stored in Y, right? Now you are importing the k nearest neighbor. So for importing the k nearest neighbor, I always used to tell you, right? So it is very easy for you. You don't have to worry or much do things much over the things. So it is the function, the function which you are going to call is k neighbors classifier, and where can you find this k neighbors classifier? It is actually under the sklearn package. In the sklearn package, there is something called as neighbors. Okay, neighbors. Inside that you can find this particular classifier function, which is nothing but k neighbors classifier, right? This is the k neighbors classifier. So when you look at the k neighbors classifier, it is actually given like by default n neighbors, and the default it is 5 number of neighbors to use the default key neighbor query. So it is basically default, it is 5, right? So all those, so there are so many different what is that parameters which are available, but we will be using only the ones which are required, right? So this is exactly what you could actually see here, right? You have so many parameters which are there, but we are going to use only the required parameters. So n neighbors, the default n neighbors which we will be using. Say if you are not giving the value here explicitly, then it is actually taken as 5. So how are we doing? This is the name which we are going to give for our classifier, so KNN, and which is the function that you are calling. You are calling the function k nearest neighbor from the sklearn.neighbors, and you are actually providing, I want the neighbor to be taken as 1, right? That's the meaning of it, and you are printing it, so you will get it as, you know, your neighbors is actually 1. Now you are fitting the iris data. So what happens is that, so whenever you have a fit function what it does is that it is you are applying the algorithm. So you are applying the algorithm with x and y. What is x and y? X is nothing but your complete input and y is nothing but your output column, right? So your complete data set you are actually passing, and what are you basically applying? You are applying this KNN function upon this particular values, right? So this is what you are doing. Now you are predicting. So when you are predicting, if you could see, I am predicting with two different with a new value. Say this is my sepal length, sepal width, petal length, petal width. All these values I am actually passing, and I want to predict upon what, based on the KNN values I need to predict. So if I run this, I will get it as, so the fitting is see, now what is the error? Because I actually forgot to run this particular code, so that's why it is saying not fitted error. So there is this fitting you have not done. That's what actually it is actually telling me. So you need to sequentially run all the things. So now it is actually fit. Now I am actually, you know, yes, it is fit. Now if I run, I will get it as actually 0. That means that 2, 4, 3, 1 actually, you know, falls into the class, you know, Setosa class, right? Now what am I doing? I am just trying to give it with different values like sepal length, sepal width, petal length, and petal width, right? And so it is actually falling into which one? It is falling into the class 2. So it is this is what something which you need to do. Now again you are actually calling the, so this line which you are seeing, you will be able to identify this. So here what are you doing? The only difference is that here you are actually giving the neighbors value as 5. Okay, so you are giving the neighbor values as 5, and you are trying to fit, and you are going to fit these two and see whether it is still falling into the same class as before. But now when you increase the nearest neighbors, you could see that here it was actually falling into 0 and 2, but here now it is actually falling into 0 and 1. So as you increase the number of the nearest neighbors, what happens? Your output also changes, right? Because finally for the majority, say for the majority selection, you are actually considering more number of people, right? Say just imagine if k is equal to 5, just imagine that you have 2 apples and 3 oranges. Then which one you will select? You will select the our data to be in the orange class, right? So as the number of the k increases, what happens? There is a higher chance that your accuracy of your data also changes and the classes will vary, right? So this is the first thing which you have to understand as part of your k nearest neighbor. This is the first algorithm that you are learning as part of the your AI program. So first one is nothing but k nearest neighbor. In k nearest neighbor, you are training all your data, and when the new data comes, you will simply measure the distance of that particular data with all other data. You will get all the distance values. Now you will, based on the k value, you will select the least 3 distances. Then based on the class that it is actually falling into, you will just go for a majority vote, right? So this is exactly what you are doing in the k nearest neighbor. So thanks a lot. Hope you understood this k nearest neighbor. So it is very, very important and very powerful supervised learning algorithm. So it is better to understand in your own way. So try, go, make your hands dirty and learn about it in a detailed manner. Thank you so much.